Welcome to this explainer. Today, we are cranking up the stakes and mapping out exactly what happens to the human body in the most explosively hostile environments in the universe. We're going on the ultimate cosmic death tour. I'm talking about the absolute worst places in the cosmos: supernovas, black holes, and massive galactic clusters.
So what would happen if you visited the deadliest environments out there? Let's jump right into this horrifyingly fun hypothetical and see exactly what it takes to get completely wiped off the face of the cosmos. Because if you thought the planets in our own solar system were rough, well, just wait until you see what the broader universe has waiting for us.
Section 1. Diving into the Sun.
We're starting close to home with our very own 1.4 million kilometer wide galactic inferno. Now, our sun is a G-type main sequence star, which basically just means it's a perfectly average middle-aged star. But up close, it fills your vision with absolutely nothing but stellar plasma. It's kind of crazy that human tech is barely scraping the edge of this giant lava soup. In 2024, the Parker Solar Probe dipped into the corona, getting just 6.1 million kilometers above the surface. Getting even that close requires insane mathematical maneuvering just to make sure you don't get permanently caught in its orbit. You know, it's actually one of the solar system's greatest mysteries why the outer atmosphere, the corona, is sitting at a blistering 2 million degrees Celsius, which is way hotter than the surface at just 5,500 degrees. But hey, either way, both temperatures will instantly fry your spaceship. Since flying through the corona's radiation and solar wind without burning up is literally impossible, for this hypothetical, we've got to imagine teleporting you directly to the surface, the photosphere. So, boom, you teleport to the surface. Immediately, you'd feel gravity 28 times stronger than Earth's, just brutally straining your entire skeleton. And it is so incredibly bright that you'd be blinded on the spot. But honestly, the crushing gravity and blinding light are just the very beginning of your problems. Let's break down the timeline of your demise here. In less than a blink, in an environment hot enough to boil diamonds, you are completely incinerated. At 0.1 milliseconds, your spacesuit chars and the visor melts. It protects you for barely a fraction of a millisecond. By 0.5 milliseconds, a boiling plasma shockwave hits, causing total organ failure before your brain can even register there's a problem. And by 10 milliseconds, your flesh, bone, and muscle turns straight into gas and plasma. In a literal flash of light, you simply become one with the sun. Okay, so what happens when gravity becomes the ultimate killer? Let's move on and see how we transition from extreme heat into the mind-bending physics of extreme density. Because out in the wider universe, heat definitely isn't the only thing waiting to tear you apart. Section 2. Crushed by intense gravity. Welcome to the twin terrors of the cosmos, stellar mass black holes and neutron stars. These are absolutely some of the most dangerous cosmic bodies in existence, and they operate on physical rules that seriously feel like pure science fiction. Now, unlike Sagittarius A star, which is the supermassive black hole at the center of our Milky Way, stellar mass black holes are the remnants of massive stars that burnt through all their fuel and just imploded. Take Gaia BH1, for example. It's a stellar mass black hole and a cosmic tombstone just 1,500 light years away from us. It has a mass about 10 times that of our sun, and it is brutally lethal. A black hole is basically a massive well of gravity sucking everything nearby right into it. And there is a point of no return, called the Schwartz radius. It's the critical distance from the center where gravity is so intense that not even light can escape. Once your ship crosses past the swirling accretion disk, that glowing, chaotic halo of superheated gas and shattered planets, and hits this radius, your death sentence is officially signed.
Now, if anyone was watching from the outside, time would actually appear to freeze as you fell in. But from your perspective, you would feel your spine and skull completely shatter as you stretch infinitely downward. You keep falling, the gravitational pull gets stronger and stronger, and it physically tears you apart. You literally get squeezed horizontally and stretched vertically until you're turned into a giant piece of cosmic spaghetti. Yeah, spaghettification is a real astrophysics term, and it's a terrible way to go.
Well, if you're trying to avoid black holes, I've got bad news. Neutron stars aren't much better. Their pulverizing pressure crushes atoms together until protons and electrons actually merge into a ball of pure neutrons. Let's look at RxJ 185635-3754. It's the closest neutron star to Earth, roaring away just 200 light years from us. It is completely bizarre. We're talking about a sphere that is only 20 kilometers wide, but has a surface that is pure neutrons and 10 billion times stronger than steel. To really wrap your head around this sheer density, a single teaspoon of this neutron star would weigh 1 billion tons. 1 billion! Because of this mind-boggling density, the star's magnetic field is so ridiculously powerful, it shorts out your ship and your suit instantly. So here is the multi-step recipe for your destruction on a neutron star. You are basically irradiated, boiled, and stretched into silly string before you can even blink. Step 1, the X-rays and gamma rays hit you, completely destroying you at a cellular level. Step 2, at just 0.1 seconds, the intense radiation literally boils your skin and blood. And step 3, finally, just like the black hole, extreme gravity grabs hold and spaghettifies every atom in your body into miles of silly string until you just vanish into the star.
Section 3. Intergalactic Smash-Up Derby. Let's leave the localized gravity traps behind and scale up to something so massive and terrifying it defies standard comprehension. Billions of light years away sits El Gordo. This isn't just a star, we're talking about thousands of entire galaxies caught in a smash-up derby, crashing into each other violently. This massive cluster collision creates a cosmic furnace, producing intergalactic shockwaves traveling thousands of kilometers per second. It is, without a doubt, one of the most lethal environments in the known universe. How hot is this furnace? Try 160 million Kelvin. Kelvin is the absolute temperature scale used by astrophysicists, and at 160 million, the heat is so completely unthinkable that your ship's computer would struggle to even contextualize it. Honestly, translating that into Celsius or Fahrenheit almost doesn't matter, because a number with that many zeros barely even seems real. So, imagine you cross into El Gordo. You immediately hit a local shock front. A cosmic shockwave shatters your ship, throwing you from the worst car crash in cosmic history directly into a wall of pure heat. You're bathed in radiation and hot gas so intense that boiling is just the first step. You vaporize. Your very atoms are instantly ionized, meaning they are completely stripped of their electrons in the middle of this massive intergalactic collision. Section 4. A brutal supernova explosion. For our final stop in this explainer, we're traveling 3.5 billion years back in time to put you in the front row for the ultimate explosion. This isn't just any regular star death. SN 2016 APS is born from a super rare situation where two massive stars actually merged before exploding. The stars collapse under their own weight and then violently erupt outward, creating the brightest, most energetic supernova we have ever managed to observe. The sheer scale of this blast is incredibly hard to fathom. This single explosion outputs a brightness roughly equivalent to the light of our entire Milky Way galaxy combined. At its absolute height, the eruption is 100 billion times brighter than our own sun. I mean, if you are anywhere nearby when this thing goes off, well, you can imagine it's not going to end well for you. The good news? Your end here is mercifully fast. The shockwave shreds your pain receptors well before you even realize you've been turned into a ball of plasma. At just 1 millisecond, a torrent of neutrinos, which are these ghostly subatomic particles that usually just pass right through matter, becomes so impossibly dense that it physically heats and ruptures your cells. By 5 milliseconds, a physical shockwave traveling at thousands of kilometers per second completely shreds your body. And by 10 milliseconds, you are nothing more than loose atoms getting carried away in a scorching ball of plasma. So having been vaporized, spaghettified, and ionized, it kind of leaves us wondering, since the universe is so incredibly hostile, what terrifying local planet should we investigate next? The cosmos is beautiful, but it's pretty clear it is entirely indifferent to our survival. Perhaps next time we'll look at something a little closer to home that is particularly good at making things die, like Venus. Until then, stay curious and keep learning.